I work at a company called Softwire, and I want to talk about microservice architecture. There's been a lot of talk about the principles of doing this well, theory and ideas, today and yesterday. And I want to really look here at a specific case study, a specific project we've done recently for the BBC, and how this architecture works, how the structure comes together, so that you can see microservices in practice, so that you can better understand how to design your own systems, how to actually put this into reality. Some context to start with. I work for a company called Softwire. We're based in London, Bristol, and Bucharest. And we build products for other people. So all sorts of people, including the BBC, but also Cisco, Microsoft, everybody. This requires that we get quite involved with the architecture. We're also often proposing entire architectures up front to systems when we're pitching for projects. We've been finding that microservices have done really quite well for us here in this sense. They give us a lot of the nice benefits that we're really looking for, and that's where we're going to be looking at today. I should notice before we go too far, we are available for hire. If you're interested in that kind of thing, if you want some developers to come in and help you build awesome products, we can definitely do that. And we are recruiting if anybody's in Bristol, London, or Bucharest anytime soon. The product we're going to be looking at is BBC Newsbeat. This is one of the many BBC News services. BBC News is obviously big and huge. BBC Newsbeat is the news service for Radio 1. So the pop, young person's modern radio channel. It's essentially providing a slightly younger twist on BBC News. So we're aiming towards 16 to 24-year-olds. We're giving a bit more music and pop culture stuff, but still bringing in lots of the more heavy-hitting, serious BBC News content. These are an interesting audience to build apps for. Polish becomes extremely important. They've been using mobile phones since forever. They care about how stuff feels. Social media integration, being able to share everything, is pretty key. And really trying to get fast information through. We're competing for attention with people like Twitter and Facebook and social media generally, and trying to get news into people's hands in quick, convenient, bite-sized formats as fast as possible is really the key thing to try and hook in here. I'm not really going to look at the sort of front-end interesting design stuff that makes this work today. What I want to focus on is the content pipeline. The process that takes news written by journalists and into the standard BBC content management systems and brings it all the way through into users' hands, and how we do that quickly and how we do that at scale. If you want to take a look at this yourself, there is a website up, obviously, bbc.co.uk/newsbeat, and the Newsbeat apps for Android and iOS. So you can take a look at that and get a bit more context. We're going to go through the UI here now, so we can see the kind of end structure and look a little bit at where the data for this comes from underneath. The main page looks something like this. We've got a series of stories about all sorts of thrilling stuff. And these we pull from existing BBC systems. We've got one system that lets us pick just what are the IDs of the latest stories, and another system that lets us pull out what have the editors selected to be the featured stories. This isn't a CRUD app. We can't just hit a database and join all this together to get data. We have to make an HTTP request to some reasonably legacy BBC systems that give us a series of IDs for this and a series of IDs for that, and then make further requests for each ID to get all the stories out. This is fairly slow and painful and takes a lot of work. We've also got a popular tab that does the same thing with another data source of the most popular stories, coming out with content in a slightly different format. We've got everything broken out by topics. This main topics page has 9 topics on it, showing the latest stories for each. But we actually track thousands of other topics. This is the core selection: music, tech, politics. But we've also got topics for stuff like Spotify or North Korea, much more specific things. And for each of these, both the core ones and the general ones, we have separate topics pages. So you can go in and pull out all of that data. And again, all the topic link graph data comes out of yet another system that we have to go and make individual HTTP requests to. We've then obviously got actual articles. I've put the whole thing down the side here to try and add a bit of context. This is where it starts to get really actually somewhat painful generating these pages. We need to be putting news into people's hands very quickly. But to generate this, we have to go to one system that gives us the content of the article, another system that gives us all the topics of the article so that we can tag it. We've then got a sidebar down the edge of the most popular articles, which requires another system, and then a query for each story to get all the content. We've got related stories that the editors have selected, and there's a footer right at the bottom of the latest stories, all of which require more and more HTTP requests. The services we're trying to talk to do this aren't co-located with these new systems. The existing journalism stack is reasonably legacy. It's been around for quite a while. It runs everything. So we can't really change it, certainly not within this project. And we're moving to AWS now for newer stuff. So we can get very quick communication with our own services, but talking to these existing services is expensive. And then, again, we've got responsive versions of these applications. So we've got similar content in slightly different formats, and we've got Android and iOS apps which don't want HTML at all, but want JSON APIs for all of the same content, again, more or less, in a slightly different format. And critically, what I want to hit home here is that we're trying to deliver quite a lot of content. We've got thousands and thousands of articles, thousands and thousands of topics. We have to be able to render everything very, very quickly, despite having data sources behind us that are expensive to talk to. Hopefully this still doesn't sound too bad. This is a largely static site. Traditionally, you'd cache the hell out of it and kind of be done with the problem. We've got a whole selection of fun requirements, though. Firstly, this is a BBC News website. It's going to get quite a lot of traffic. We're aiming for 2 million users a day average. That's a benchmark that Slack reached in December. So we're pretty big, and we're building this whole thing from scratch in about 4 months. On top of that, this is a news website, so it is incredibly spiky. All of a sudden, Kanye West is going to tweet a link to a story about him, and all of his followers are going to click it, and we are going to get a vast wave of traffic suddenly coming through. We have to be able to deal with this. We have to be able to deal with this really fast and very reliably. Again, that you can manage by just caching, more or less. More problematically, we have to be able to get news out very quickly. A really common pattern for the journalists here is to start writing an article when you've got some breaking news, release it as a very short snippet, and then update it 30 seconds later with a bit more content and a bit more content as the news comes in. And we need to be able to push those out. Again, we're competing with Twitter and people, and getting up-to-the-minute news is very important. We have to push news stories out very quickly. We have to push updates out very quickly. And we have to be able to do redactions extremely quickly and reliably. If it turns out, as the BBC, we've published the wrong news, we have to be able to take it down. And we've essentially got a hard limit that we have to be able to take any content and update it or remove it from anywhere that it's currently published within a minute for any of these thousands of articles or pieces anywhere. So we've got a big, fun cache invalidation problem, which is famously easy. On top of that, the back-end services, as I've mentioned, are a bit tricky. Not only are they a little difficult for us to use and quickly get data from, they're also really important. We can't release the system if there's any chance that it might flood the back-end systems with traffic. These systems also provide journalistic content to BBC News itself, to the scrolling tickers that you see on the TV, to huge numbers of sources. They're extremely important, and there is no way we can release anything that puts them at any serious risk. I think other people have been talking about stuff like circuit breakers and flagpoles to manage and disconnect from systems when they're under strain. we have to keep all of that kind of stuff in mind, and if possible, end up with an architecture that is going to make it really difficult to flood these backend systems. Part of this is that if at any point we get an error from the backend, we have to just serve the last stale content, if we've got any, indefinitely. If at any point a request comes in for something, we try and look it up and we can't get it, we just have to serve stale content. And we, if possible, want to do this 100% of the time. Also, we like to serve stale content while we're revalidating. If a request comes in for some content and we're going off to do some slow requests to actually regenerate the article page, we need to serve the stale content in the meantime, rather than ever having users waiting for those slow requests. And then finally, there's a long stream of other interesting requirements, which I'm not really going to talk about, but there's a lot of stuff going on here. Being an agency is occasionally somewhat difficult, and particularly when you're working for big, high-profile customers like the BBC, you have to be able to do stuff really well and really reliably under somewhat tricky conditions. What I want to do now is start with a very naive, basic solution to this problem, and then step by step look at why it doesn't work, and build up and progressively produce architectures that do work better. Look at the problems with each architecture and look at how we can transform it to solve them and do better. We need to get something that can handle all this traffic, that can quickly publish and update content, whilst being very reliable and working with a less reliable and certainly slower backend that we have to be quite careful around. I should be pretty clear here that this isn't stuff that Softwire have magically come up with on our own. A lot of these ideas are things the BBC have been developing for quite some time and frameworks that they've been starting to put together. This is the first time that this has been actually put into place on a full application like this. This is the first time we've really tried to take these ideas and use this to solve these kind of problems at scale. We'll start with a very simple solution. When a request comes in from the website, we will go off to the back end, load all the data for the article page, say, stick it all together into some nice HTML, and serve it back up in a nice big service that knows how to do this for every page and every endpoint for JSON that the apps need. This is a simple and effective way of getting this done in very small scales without most of the problems we've talked about here. There's a whole range of stuff that isn't going to work here, but number one, trying to actually handle much traffic with this is going to be really hard. We are going to have trouble scaling this out. We're just going to have to run thousands and thousands of instances of this thing that is constantly getting hammered by our millions of users. And even if we do that, the requests that come through it are going to crush the back end. They're going to leave it as a mark on the floor. It's going to be completely dead. BBC News is going to go down. It's going to be international use, and we're going to be in a lot of trouble. So we want to take this, we want to try and make a change to it that is going to allow us to handle more traffic. And the first step is pretty simple. We stick a cache in front. Requests come in, and if we've recently served the same request, we just serve it straight back out. And if we haven't, the request goes through the cache, loads the data, builds the HTML, sends it back, and so on. We, in the BBC case, use Varnish here for this, which works pretty well, gives you a lot of nice flexibility and power, and will do stuff like stale on error and stale on revalidate most of the time with a bit of fiddling. But this still doesn't quite solve our problem. Critically, sometimes we're going to get cache misses. The very first time a request comes in for content, for example, there's not going to be anything for it in the cache. And that is going to have to wait until it hits the back end, hits the many other backends, gets content back out. And all the users who are there at that point, when we publish something new, or if content has been completely evicted from the cache, all those users are going to get blocked for ages. That sounds like it should be a fairly niche case, but particularly in news, this is quite a problem. You publish a story, it goes right to the top of the homepage, and thousands of people are going to click it straight away. If that page is going to sit for second after second generating, this is pretty bad. And we've improved upon the previous solution, but this is still a problem that isn't going to be okay. Critically, we're doing the rendering work and the data load synchronously on requests at this point. There is a case where requests actively wait for us to go and do all these operations. We also have a tricky case with when we actually do our data reloading. If the time to live, the expiry on our cache, is an hour after the content first goes in there, then we don't end up hitting the backend services for that content very much. On the other hand, though, we don't get new news for an hour. Our news is an hour out of date, and that potentially is pretty bad. We certainly can't go live with that kind of performance. If, on the other hand, we set our expiry at about 30 seconds, then we do get new news. Stuff comes through within 30 seconds, more or less, which is pretty good. But we're going to be hammering the backend services. If you've got a popular article and we go and we regenerate all the stuff every 30 seconds, then we end up doing loads of extra data loads, loads of extra pain. And critically, we don't have that much control over when this rendering happens. It's all dictated by how many requests are coming in, and the only dial we've really got to manage this is the expiry we set in the cache. So we need to take this. We need to remove data loading and rendering from being synchronous on requests, ever, if possible. And we need to get more control over when data loading happens so that we can do it less or more efficiently. The very first step to prove that is to simply pull data loading out. Here we have a separate service that, on a timer, goes and gets all the latest and most popular content, whatever articles are around, pulls in the latest data, and stores that into some data store. And then all that requests actually do is come in, read from the nice, local to our services data store, put that content together and serve it up. And all of a sudden, we're doing far fewer requests to content services with more control. There's still some problems and details to work out here, but we've gained easier control over when data loading happens. And critically, there's no way that requests can come in and get blocked waiting for the backend services. We've removed expensive operations from ever being on the request path here. And we're starting to see the bits of the actual content pipeline data taking step by step towards the users rather than users waiting for stuff. This still doesn't actually really solve our when do we regenerate content slow publishing problem. If that timer updates everything every 30 seconds, again, we're hammering traffic. If we do it every hour, again, we get late news. We have more control. So, for example, we could now really easily look at the popular data and update the most popular or the newest articles every 30 seconds, but last week's articles every hour, every day, whatever. We get more control, but this still isn't perfect, and we can do better. If we take this architecture, we need to find a transformation that allows us to make requests to the backend only when they're really necessary. We need something better than a timer to control this. Unfortunately, that's available. The BBC now have notifications they can provide us with. They've hooked these into SNS. SNS can be hooked into SQS. These are Amazon's notifications and queuing systems. And we can use this so that our data load gets messages on a queue that say something like, Article 3 has been updated, the latest feed has new content, etc., etc., and can get pinged when they need to go and do data loads. Just like this, we put ourselves in a position where we only do data loads on demand. We're starting to push content down through this rather than actively pulling it. So we get a notification for an article, we load all the data for the article, we put that data into our data store, and then later requests come in, read the data from the data store, put together a page, serve it out. Again, still data loading, the most expensive part, is taken off the critical path, and we're never waiting for that now. It's still not quite right. We've pulled some stuff off the request path, but Still, every time we get a cache miss, we have to go and get all these bits of data, now just from a local data store. But we have to go and get all these little bits of data and put them together to build a page. And we're repeating that work kind of unnecessarily, and it's a bit messy, especially given the change we've made. So what we'd really like to do is take this architecture and not re-render the pages every time stuff comes through the cache. This bit's pretty easy. We just re-render it when we load the data. When I get a notification saying an article has changed, I go off to the content services, I get all the data for the article, and then I actually generate the HTML and JSON that people are going to need later, and I put those direct bits of content into S3 as a data store. And this means we're doing even less stuff on the front end. This also gives us some interesting flexibility. On the article page, not everything changes when article text changes. So there's a footer of latest stories, for example, and this is the same for every article, and similarly, the most popular sidebar. It would be nice if, when article content came in, new article content, we didn't regenerate that for all of our thousands of articles. With this, we can now do these separately. When we get an article notification, we render the HTML for just the text of the article, and we store that. When we get a notification for the most popular data, we render the most popular sidebar and the page. And then on the front end, we can just take these chunks of HTML and stick them together. This allows us to separate the various bits of the page and, again, reduce the amount of extra work we're doing. Most interestingly here is that S3 lets us completely decouple things now. Content's just coming in, we're rendering it, we don't really know where it's coming from or what's happening in the back end, which lets us make some cool changes. For example, all of our rendering at the moment happens in one big service. Maybe you can see where I'm going with this already. We'd quite like to be able to render other kinds of content in future. We're going to have more types of articles. We want to publish videos. We want to be able to put tweets into feeds, all sorts of crazy stuff. To do this, we need to be able to easily change how rendering, how data loading works. And with this, at the moment, any time we try and change that, we're going to have to change the whole of this service, which is actually kind of important and does everything. It's also not very reusable as it is. If we want to do a new news service that has similar feeds of stories and articles, but take some of the code we've actually done here, at the moment we have to take that whole service and then change it. And it would be better if, for example, it was a bunch of smaller services. And all of a sudden, these become much easier to change. If we have another news service that has similarly formatted articles, our article renderer alone can just be taken directly and put it into the next service because it's separate to how the rest of the layout works. Quite excitingly, we can do this, and the front-end service, the service actually serving things, doesn't know anything about it. Because these are separated through some dumb layer here, S3, we've gained huge flexibility to change stuff. We could have actually put this system totally live, then made this change, and not touched the front end or even taken it down at all. All the front end does is read stuff from S3. Even if you turn the renderers off, you can still read stuff from S3. The site still works fine. You don't get new news yet, but you've got a lot more flexibility to change those services without it ever impacting what users end up seeing. And you've also gained flexibility for scaling, particularly here. We get a lot more articles being published and changing than we do some of the different topics, this kind of stuff. These want to scale independently, and moving towards the microservice approach, like we're doing here, starts to give us that. Again, we can do better. So with this architecture as it stands, we've still got another big blob left in the front end. Currently, when requests come in, that front end has to go to S3 and find the text for the article and the footer and the sidebar and the header, and then find the HTML template to stick those all together, and then build a whole page and then serve them back. That's a reasonable amount of logic. Interestingly, that's not logic that the apps especially really need at all. There's a whole bunch of stuff in here that they don't care about. All the apps do is hit this service, asking for the article JSON, and the service hits S3, gets the JSON, and gives you it back. It's very dumb. There's quite different use cases for these. And these different use cases make it easy to spot seams, spot places where we can start to take these services apart, like so. And this is more or less what we actually end up with for the Newsbeat architecture. We have a composer, which just looks up bits of content and sticks them together with an HTML template to build whole pages. We have a broker, which understands how to go to S3 and, say, find the HTML for article 12. This kind of thing. It knows how to manage the lookup and stuff, which is all the apps particularly actually need. And then we have this renderers running the back-end services. When we get new content coming through, it's pushed straight through the pipeline. So we get very quick updates. If we get a notification, say, on our queue, that article 4 has been updated, the article renderer then goes and queries all the data for article 4 and generates the HTML and JSON blobs for this and drops them into S3. The next app requests that come through the cache and hit the broker will immediately just see that JSON. And because the broker and the composer are doing very, very cheap operations, we can keep the caches at the front here very short-lived, 30 seconds, 20 seconds, this kind of thing. And reading through becomes quite cheap. We've taken nearly all the work off the front end. It's very, very difficult to make a front-end request that can ever be slow because nothing's happening. Any requests that come in do basically nothing. This is kind of almost it's a very unusual architecture. It's almost the opposite of what we did at the start. Requests come in and they do a bunch of work and they go back out. Now they come in and they do pretty much nothing. All the expensive operations have been taken to being pre-rendered, done in advance. It's really interesting to look at architectural posts from people like Twitter, where they're doing these. They've got similar constraints on a much bigger scale to this sort of stuff. You've got a lot of content available, you need to handle a lot of traffic, but you also need to be able to publish and push content through quickly. The way you do that is doing stuff in advance. In Twitter's case, when you get to a tweet, you get all the followers for that person and you manually update the list of tweets that they've got waiting for them. You go and you pre-render their timelines, essentially, in advance, rather than doing it on request. And this lets you get these kind of structures and gives you a whole bunch of other quite cool benefits. Internally, a few technical details. This is running on Ruby because the BBC are moving towards Ruby. It's AWS for everything else, pretty much. So EC2 servers for all our little instances. We use S3 and Dynamo to look up and actually store all the little blobs of content. There's some Elasticache between each individual service, just in case we quickly re-render things to make that nice and fast. SQS and SNS give us notifications to push things down the pipeline into users' hands, and CloudWatch gives us really easy monitoring. When you've got a system like this where the components are very dumb, so SQS and S3 particularly, it's really easy to work out at a basic level whether stuff's working. CloudWatch for free gives you, more or less, gives you monitoring to check the size of your and you can really easily start to monitor this kind of stuff once you've got these quite dumb, simple tools in between them. This is actually built on a framework which we've been contributing back to as we've done this. The BBC have made this public now, Elephant. You can go and check it out. It's a strange spelling. I'm not quite sure why that exists. Internally, it's got proof of concept working renderers and brokers you can pick up and go. The composer exists there as well, and you just need to give it HTML templates and tell it the name of the content you're looking for. And you can bring all these patterns in really, really easily. And they work very well for us. They're very powerful and solve these problems really nicely. It's very worth looking at. A quick recap just to start finishing up here. How does this actually really do what we were trying to do originally? Fundamentally, it's just very fast, because when requests come in, we don't do anything. As much as possible, when a request comes in, we avoid really doing any processing. We've got some expensive stuff to do, and we'll just do it all in advance. We'll just completely avoid doing requests synchronously, doing work synchronously on requests. Instead, we do it in advance, and we use a pipeline pushing that content, notifications, and very short-lived caches to allow us to quickly send content straight the way up here. It's also very robust, because all the work is done in advance. If that work stops happening, you've still got all the content cached in S3. If the renderers just explode and die, the news keeps going. Stuff is still available in S3, everything still goes. We don't get new news in the meantime, but that robustness gives us all sorts of interesting benefits. We don't have to worry particularly about deployments for renderers. If they break, we just put up a new one. Nobody's really going to notice, nobody's going to worry. It's very hard to actually break stuff, which is really nice. And is the kind of thing that caching gives you generally, but here we're caching all of our work in advance and using push down this pipeline to stop those caches actually giving us very old data. We also get fantastic encapsulation and decoupling between the components here. This is an architecture that ties really nicely into microservices. By having all these separate different areas, you've moved into a place where it's really easy to split up your services. And this gives you really cool features. Monitoring becomes really easy. Monitoring for microservices generally is a reasonably involved problem, but when most of your interactions are with dumb, simple systems like SQS and S3, you can very easily just drop in standard tools to understand them. You can also drop in other interesting tools on top. So the broker, for example, when it looks up content from S3, has no idea where it came from. If, in the apps, you want some other content to be available, so in our case, the apps look up some dynamic configuration, they go and get some JSON, you can just drop that into S3, and then the apps can hit the broker, and the broker will serve it just as normal. We've got a very simple tool that just writes some JSON into S3 in a specific place where we like, and in the apps, we just look up, ask the broker for the app config, and all of the standard pipeline just works, and the broker doesn't know any different because it's totally detached from everything else. We can also trigger re-renderings really easily. The renderers don't know where their messages come from. We can drop a message into the article queue saying, please update article 4, and it'll go and do that as if article 4 had actually changed. If that article's been corrupted or something, we can just trigger that very easily. And again, because SQS is standard tooling, it's really easy to build tools that just add a message to a queue. And we can also do things like re-render all our content. We actually had to do this. When we released Newsbeat, they already had an old legacy site up which had a whole bunch of stories on it. We had to re-release all these stories so they were still available. And you can do that really easily in this infrastructure. You just get the IDs of all the historical stories, and you put each one onto the queue one by one at a steady rate so you don't swamp anything. But you essentially pretend that every article had just been updated, and it goes through and re-renders the whole lot. And again, dumb, simple tools here allow you to have really great flexibility to add in extra little bits that hook in into various places in the infrastructure. This is not all roses. There's extra difficult stuff that happens if you try and do this. The number one bit for microservices generally, of course, is that stuff is just more complicated. If you don't need to do this, don't. These are quite specific constraints. We have to handle a lot of traffic, and we have to also get content out very quickly. If you're not doing that, you don't need to do that. You don't need to do this. If you are doing that, even in that case, there are a few specific challenges that you need to watch out for. For example, everything has to be cacheable. It's really easy to get caught out by this. So the articles, for example, have times on them, published 5 minutes ago, say. at the top. And that's a relative string. You cannot cache that. If you put that in the cache, you're going to be wrong 2 minutes later. So in little cases like this, you have to move bits of processing to the client side instead. We actually publish fixed times, and then JavaScript swaps them out for relative times, and the Android and iOS apps convert them themselves. But you have to be aware that everything has to be completely cacheable. You can't have user-specific content in here, really, and you can extend the architecture to do that. But with the simple setup as it stands, you're quite limited in exactly what you can publish and push through. You also have to worry about data migration. If you want to change the structure of the JSON that you serve to the apps, then you're in a difficult place. You can't just change the thing that serves the requests and have it serve different content, because you've already served all of the JSON in advance. It's already stored. You can't easily change the logic that renders those. And if you want to do that, you have to change the article renderer, say, and re-trigger a render for every single article you've ever published. And potentially, if you've already got apps live, depending on the current structure, this can get quite difficult. In our case, it has been fine. If you're just adding extra content to it, it's largely OK. For old articles, it will just be missing, and you ignore it, and it's all right. But if you were doing more difficult stuff, you can definitely see cases where this kind of thing could blow up in your face and cause problems. Code sharing between these is quite hard and quite common when you've got lots of renderers like this that are all different but doing kind of similar problems. For example, the feed renderers all come out with the same sort of card structure. You're going to end up with bits of code sharing. And we don't actually have a particularly good solution to this. We're using gems and dependencies. So we've got small libraries that get included. Some people would strongly suggest with microservices you should not share any code, and you should simply duplicate code between them. I think this works better than that for us, certainly, although there is still effort involved. Mono repos have been suggested as a quite good solution. Many microservices, but within one Git repo, so you don't have to manage your dependencies too much. Perhaps if you've got any shared code, we should be going even further down microservices and pulling them out into extra services that do templating for each card. I don't know. There's a lot of different options here, but this has been something that's reasonably painful and that you have to watch out for. Finally, did this actually work? Is this a success? Yes. If you want, you can go and have a look. There's a website, there's an apps. There are apps. They're very fast. They don't go down even when Kanye West tweets about us. It works, and it very nicely actually solves our problems, which is great. Both Softwire and the BBC are very happy with how this has gone. It's difficult, obviously, because we're a bit biased, so I'll leave the final words to probably my favorite review for the Android app ever, Keith TV, who is extremely impressed with how this works. I think this is probably the best review I will ever get for anything I ever do. It's good to have. Cool. OK, so that's everything I've got. I think we might have a couple of minutes for questions. Again, I'm Pim Terry on Twitter, and I'll stick these slides out later so you can go and take a closer look at exactly how all of the finer details of this work. And again, I do work for Softwire, and we are hiring and available to be hired if you're interested in that kind of thing. Thank you very much. Any questions? From the front?
Yes, so the architecture, did it evolve actually like you presented it, or was this for the sake of the presentation?
This was for the sake of the presentation. Yeah, it's reasonably complicated, and it's difficult to jump straight in. We pitched this almost exactly as we ended up with at the beginning. The few bits that kind of caught us out and needed small changes were things like redaction and stuff, where you've got some actually quite tricky bits and pieces. You have to start returning 404s for articles that previously existed. There's some interesting cases there. But by and large, we came up with the core design in advance. Anybody else? So you can do that. If you really invest in Varnish, it does have some features. You have to get Varnish Pro, I think. I'm not sure. They have a paid extra version that gives you really fine control over cache invalidation. if you start to do that, it becomes quite a bit more complicated working out exactly how this works. One of the nice bits about this architecture is that each individual bit is actually very dumb, and most of the nice features we're getting come out of the structure as a whole rather than specific implementations. But there definitely is a route through doing that. And yeah, you totally could do that. It's probably the sensible choice if you've got these problems on a slightly simpler scale. If most of the time you don't need to be pushing content and you need to scale, and occasionally you need to be able to invalidate stuff, that's probably the more sensible approach to go. There was somebody else at the back? Yeah. Yeah, so everything auto-scales. The auto-scaling is pretty easy here. All of these services, again, very dumb, very simple, so they're very stateless. You can just run as many brokers as you like. Nobody really cares. And it's also quite easy to monitor exactly how much they need. The broker and the composer, you can just check what kind of CPU loads they're under, really, by and large. The renderers particularly just have a queue, and if the queue gets too big, we just start another renderer. And then if it's small for a while, we turn one off, and this kind of thing. It's surprisingly small. Certainly maybe 10 or so max of any individual thing, because we cache it very heavily on the front, and you can do it quite well. But I don't think I can go into exact specifics there, no. Anybody else? Okay. Ooh. To write the microservices. It's Ruby underneath, all the code for these. The framework, yes, is Elephant, which is also Ruby. The framework underneath is mostly using Sinatra for the actual serving of web requests, and the renderers are just using an amalgam of standard Amazon SQS communication stuff. They're not doing anything particularly clever. Keeping it really simple is where a lot of the power comes from. Any more? Cool. Okay, let's go and have some coffee. Thank you.